So in this video, we will be solving February-March 2025 question paper 1, variant 2. Let's start. So question 1 states that which quantity is a scalar quantity? If you talk about force, force is a vector quantity, momentum a vector quantity, velocity a vector quantity, work is a scalar quantity. So the answer to question number 1 is T. Moving on to question number 2. What is the effect of a systematic error on the measurement of a physical quantity? It limits the precision of the measured value? No. It limits the range of values obtained in repeated measurements? No. It results in repeated measurements having different values from each other? No. It results in the measured value being different from the correct value, and that is the right answer. When you talk about systematic errors like zero errors, what they end up doing is they basically result in your measured value being different from the correct value. So if there's a systematic error of, let's say, 2, your value would be either be 2 greater or 2 lesser than the correct value, irrespective of how many times you perform the experiment. Moving on to question number 3. Question 3 states that a car is accelerated by a constant resultant force of 300 Newton for 5 seconds. The variation with time of the velocity in centimeters per second. So this here is the keyword centimeters per second of the car is shown. What is the mass of the car? Now for a velocity time graph would give you the acceleration of the car. So if you talk about the acceleration which is final velocity minus initial velocity divided by time, that would be 150 minus 30, but since the speed is in centimeters per second, we multiply it by 10 to the power minus 2 to convert it into meters per second, divided by time, which is 5 seconds. So that gives us the acceleration as 24 meters per second squared. Now, what is the mass of the car? We know that force, the resultant force is equals to mass times acceleration. The resultant force given in the question is 300 Newton, with the mass of the car being our unknown and the acceleration being 24. So M comes out to be 1250 kilograms, which when rounded off to 2 significant figure gives you the answer as C, 1300 kilograms. Moving on to question number 4. Question 4 says an aircraft initially stationary on a runway takes off with a speed of 85 kilometers per hour in a distance of no more than 1.2 kilometers. What is the minimum constant acceleration necessary for the aircraft? Now, once again, the problem with this question is you've got the speed as 85 kilometers per hour. This is the takeoff speed. You know that the initial speed is 0. Meters per second, kilometers per hour doesn't make a difference. And then the distance is 1.2 kilometers. So we've got two options here. Since they need the acceleration in meters per second squared, we can either convert 85 to meters per second and 1.2 kilometers to meters and then work out the acceleration. That would result in the answer being in meters per second squared directly. Or what we can do is we can work out the acceleration and then convert that acceleration into meters per second. So if I go with the second option, I will use the formula. As we know, v squared is equals to u squared plus 2as. My final velocity is 85. Keep in mind this is kilometers per hour. My initial velocity is 0. My acceleration unknown. And my displacement is 1.2 kilometers. And when you work this out, this comes out to be acceleration equal to 3010 kilometers per hour squared. Now what do we need to do? We need to convert this kilometers per hour squared into meters per second squared. And this is where I believe a lot of students end up having trouble. How do you convert kilometers per hour squared into meters per second? Now what does this mean? This means that 3010 kilometers per hour squared. or I can say that the speed of the aircraft increases by 3 kilometers per hour, 3010 kilometers per hour every hour. So kilometers to meters, you multiply it by 1000, and hours to seconds, you multiply it by 3600. But since this is r squared, you multiply it by 3600 squared, but in the denominator, or you divide it by 3600 squared, depends on how you look at it. And that gives you the answer for acceleration as 0.23 meters per second squared, the answer being A. Let's move to question number 5. Question number 5 says an object is fired upwards from horizontal ground. The object has an initial velocity of 20 meters per second at an angle of 45 degrees to the horizontal. Air resistance is negligible. Which statement describes the speed of the object after it is fired until immediately before it reaches the ground? So its speed decreases. Obviously, the object gains gravitational potential energy, which means the kinetic energy would decrease and the speed would decrease. So its speed decreases, that is correct. And that is given in all the options. To a value greater than 0. So to a value greater than 0, why doesn't the speed become 0 meters per second at maximum height? And the reason behind that is that for this object that is fired at an angle of 45 degrees, even at the maximum height, the object will have a horizontal component. So since there is a horizontal component, the object still has speed. So the speed will be a value greater than 0. And then it increases to 20 meters per second. So when it comes back down to its original position, before it reaches the ground again, and when it reaches the ground again, the gravitational potential energy gets converted into kinetic energy again. So the object ends up with the same kinetic energy as it started with. So it will have the same speed, which is 20 meters per second. So the answer is A. Let's go through all the options and see what the problem is. So option B says its speed decreases to a value greater than 0. All is well up till this point. Then increases to a value greater than 20 meters per second. No, that is incorrect. That would happen if the object was landing at a position that was below the initial position. So let's say an object is launched from a cliff, it goes up and lands up at the ground some place below its starting position. In that case, the speed would be greater than 20. Its speed decreases to 0. Decreases to 0. C and D are both incorrect because the speed does not decrease to 0 unless the question was about an object that is fired vertically upwards and has no horizontal component. Then the speed would decrease to 0. So C and D are thus incorrect. Question number 6 says, what is the statement of the principle of conservation of momentum for a system? The total momentum and the total kinetic energy are always conserved. No. Kinetic energy has nothing to do with the principle of conservation of momentum. The total momentum is conserved only in elastic collision. No. Total momentum is always conserved. The total momentum is conserved provided that no external forces act. That is correct. The total momentum is conserved given that it's an isolated system. It's a closed system. There are no external forces acting. Option D says the total momentum of each object in the system is the product of its mass and velocity. So momentum is part mass into velocity, but that is not the principle of conservation of momentum. Moving on to question number 7. Question 7 says objects P and Q form an isolated system. Object P has a mass of 6 kilograms and is moving at a speed of 3 meters per second. Object Q has a mass of 2 kilogram and is moving at a speed of 4.2 meters per second at an angle of 35 degrees to the path of P. Objects P and Q collide and stick together. What is the magnitude of the component of the final momentum of the combined objects in the original direction of P, which means horizontally? What is their final horizontal momentum? Now, since momentum is conserved, you need to understand that momentum is a vector quantity. And because momentum is conserved, what they're trying to say is momentum in a linear direction is conserved. So the initial horizontal momentum should be equal to the final horizontal momentum. They're asking us for the final horizontal momentum, and I know that should be equal to the initial horizontal momentum. So initial horizontal momentum for P is 6 kilograms multiplied by 3 meters per second plus the initial horizontal momentum for Q would be 2 kilograms multiplied by this component of velocity, which is 4.2 cos 35. So minus 2 into 4.2 cos 35. Where does this negative sign come from? These two travel in opposite direction. The 6 kilogram mass is traveling to the right, hence we have considered that velocity to be positive. The 2 kilogram mass has a component, horizontal component to the left, so that has to be negative. And when we work this out, this comes out to be 11.119, which rounded off is B, 11 kilogram per meter squared. Okay, so question number 8 now. Question 8 says, now this is a trick question. An astronaut of mass m in a spacecraft experiences a gravitational force. F is equals to mg when stationary on the launch pad. What is the gravitational force on the astronaut when the spacecraft is launched vertically upwards with an acceleration of 0.2 g? Now a lot of students would add the 0.2 g to mg and give the answer as 1.2 g. There are students who subtract 0.2 g from mg and give the answer as 0.8 mg. But you need to understand that the gravitational force does not change. It's equal to the weight, and that is equals to mg. So irrespective of whether the spacecraft was stationary or if it is launched with an acceleration of 0.2 g, the gravitational force still stays mg. So the answer is B. Moving on to question number 9. Question 9 says the diagram shows a child X of mass 20 kilograms and a child Y of mass 15 kilograms seated on a uniform plank. The plank has a mass of 7 kilograms and has a pivot at its midpoint. The plank is horizontal and in equilibrium. Which statement about the weight of the plank is correct? Now, the key word here is that the plank is uniform and it is pivoted at its midpoint. So for uniform objects like this plank, the midpoint is at the center of gravity is at its midpoint. So the weight of the plank acts from this point and passes through the pivot. So which statement about the weight of the plank is correct? Statement A says the weight of the plank can be considered to be acting at its midpoint. That is absolutely right because it is a uniform plank. The weight of the plank is causing an anti-clockwise? No. Clockwise? No. The weight of the plank equals the force on the plank from the pivot? No. That is also incorrect. Moving on to question number 10. An object is fully submerged in a liquid. A student determines the ratio of the upthrust acting on the object to the weight of the object. Which single change would double the value of the ratio? So if you talk about the upthrust on the object, upthrust is equals to rho, the density of the liquid, multiplied by gravitational acceleration, multiplied by the volume of the object, because this is the volume displaced by the object, volume of the liquid displaced by the object. And when you talk about the weight, weight is equals to mg, or I can say it is density of the solid multiplied by volume of the solid multiplied by g. Option A says use a different liquid that has twice the density and the same volume as the original liquid. So if the density of the liquid becomes double, the numerator becomes double and the ratio becomes double the previous ratio. So answer A, option A is the answer. Option B says use a different object that has half the volume and the same density. Now the volume of the liquid does not make a difference. As long as the object is fully submerged, it does not make a difference what the volume of the liquid is. An object could be 1 meter below the surface of the liquid, it could be 2 meters below the surface of the liquid, or it could be 10 meters below the surface of the liquid. In all of these cases, the upthrust that it experiences stays the same. Option C says use a different liquid that is twice the density and use a different object that has twice the density and the same volume as the original object. If you double the density of the object, the mass of the object doubles and the weight eventually doubles, which means the denominator doubles. So what that does is that halves the ratio. The ratio becomes half the previous value. Use a different object that has twice the volume and the same density as the original object. So if you double the volume of the object, the mass of the object doubles, right? So the weight doubles. But the numerator also doubles because this volume is also the volume of the object. This is the volume displaced by the object. So the numerator also doubles. So the ratio stays the same. Okay, that was question number 10 with the answer being A. Moving on to question number 11, which states that a shop sign weighing 75 Newton hangs from a frame attached to a vertical wall. The frame consists of a horizontal rod XY and a rod YZ that is at an angle of 30 degrees to the horizontal. Rod XY is attached to the wall by a hinge at X and has a length of 0.5 meters. Assume that the weights of the rods are negligible. What is the horizontal force exerted by the wall on the rod? So they're asking you for the force that is exerted by the wall on the rod. They're talking about this force. Now, there'll be tension in this rod YZ, and this would be the direction of the tension. This tension will have a vertical component which will be equal to T sine 30, and the tension will be equal to will have a horizontal component which will be equal to T cos 30. If you talk about principle of moments, and if you take this as the pivot, the moment due to this blue force, which is the force that the wall exerts on the rod, this will have a moment equal to 0. The moment due to T cos 30 will be 0 because both these forces pass through the pivot, which is at position X. The clockwise moment due to the weight of the sign will be equal to the anti-clockwise moment due to T sine 30. And since the two forces are at the same distance, so let's say moment in the clockwise direction is equal to the moment in the anti-clockwise direction. The clockwise moment is 75. Let's say the total length of the rod which is given is 0.5 meters. This will be equal to the anti-clockwise moment, which is T sine 30 multiplied by 0.5. The 0.5's cancel out and you end up with T being equal to 150 newtons. Now they're asking you for the horizontal blue force that we have marked, that is equal to T cos 30. So let's work out T cos 30. Let's say this force is X. We know X is equals to T cos 30. So 150 cos 30. And that gives you the answer as 129.9 newtons, which when rounded off is equals to 130 newtons. So the answer is C. Question number 12 says, a student takes measurements to calculate the density of a liquid in a beaker. The height of the liquid in the beaker is 0.2 meters plus minus 2%. The internal diameter is 0.05 meters plus minus 3%. And the mass of the liquid is 0.36 kilograms plus minus 10%. What is the percentage uncertainty in the calculated density of the liquid? So when you talk about the formula for density, the formula for density is mass upon volume. For this liquid in this beaker, the beaker is a cylinder. I would say mass upon base area using the internal diameter cross-sectional area multiplied by height. Or I can say mass is equals to, instead of area, I can say pi d squared upon 4 multiplied by height. So to calculate the percentage uncertainty in density will be equal to the percentage uncertainty in mass plus 2 times the percentage uncertainty in density plus the percentage uncertainty in height. When two or more quantities are being multiplied or divided, the percentage uncertainties get added up. And if you've got a power there, let's say you've got power 2 over here, or you've got something raised to the power half, which is basically a square root, you multiply that power to the percentage uncertainty of that quantity. So mass has a percentage uncertainty of 10% plus 2 times the diameter, the percentage uncertainty in diameter, which is 3%, plus the percentage uncertainty in height, which is 2%. This added up gives you 18%. So the answer therefore is D. Moving on to question number 30. The diagram shows a uniform plank XY of length 4 meters and the weight 300 newtons. The plank rests on a fixed position support at its ends X and Y. A child of weight 600 newtons stands in different positions on the plank. The support at end X exerts a force F vertically upwards. So end X exerts a force F vertically upwards. So there is a force in the upwards direction at position X. Let's call this F. What is the magnitude of F when the child stands at X and when the child stands at Y? So when you talk about the total downward force, the total downward force is due to the weight of the plank itself, which is 300 newtons, which acts at the center, and it is 600 newtons due to the weight of the child. So assuming that in the first case the child stands at position X, so you've got the child here, a poorly drawn one, but you've got the child here standing at X. This time around the 600 newtons in X over here. Let's remove this from here, and the 600 Newton weight acts at this position X. So the total downward force is equal to 900 Newton. For this object to be in equilibrium, for the support, for this plank to be in equilibrium, the total upward force should also be equal to 900 Newtons. There's only one option that gives you the answer as 900 Newtons, which is option D. Okay, we can also do this using moments. So if I were to take position X as my pivot, so this position as my pivot, and if I talk about the clockwise moment due to the 300 Newton force and the anti-clockwise moment due to this force at Y, this would be 300 multiplied by 2, sorry, and this would be 150 multiplied by 4. 300 multiplied by 2 gives you 600, and 150 multiplied by 4 gives you 600. So that also gives you the value as 150 newtons. 150 newtons. So the answer therefore is D. Okay, moving on to question number 14. Which relationship is used in the derivation of the equation of power? So power is defined as work done per unit time. Work done is force into displacement, force into displacement, displacement divided by time. And what is displacement upon time? Displacement upon time is velocity. So power is equal to force into velocity. So the first equation, which is displacement is equal to velocity into time, this is used in the derivation for power is equal to force time velocity. Question number 15 says, a block is released from rest at the top of a slope inclined at an angle to the horizontal. The slope has length L as shown in the diagram. There are no resistive forces acting on the block. What is the speed of the block at the bottom of the slope? So the energy conversion that's taking place in this question is gravitational potential energy gets converted into kinetic energy. So I can say mgh is equals to half mv squared. The m's cancel out. So when you talk about v is equals to square root of 2gh. Now h needs to be the vertical height. It has to be the vertical length, which is this thing here. This here is our h. And we know H is equals to L sine theta. So I can write this as under root 2 into 9.81 into L sine theta, or under root 19.62 into under root L sine theta, which is equals to 4.43 L sine theta with L sine theta under root. Even if you don't do this entire question, you can just look at the options and know that it has to be the sine component. So it has to be either B or D based on this fact. And because there's a square root, it cannot be 19.6. It has to be 4.43. So the answer is B. Question number 16. Okay. Question 16 says a skateboarder and a skateboard have a total mass of 70 kilogram. She pushes on the ground with her foot to create a forward force of 25 Newton on herself and the skateboard, as shown in the diagram. The skateboarder and the skateboard travel a forward distance of 0.5 meter before the skateboarder lifts her foot from the ground. What is the work done by F on the skateboarder and the skateboard? So when you talk about work done is defined as force multiplied by displacement in the direction of that force. So the force is 25 newtons multiplied by the displacement is 0.5 meters, which is equals to 12.5 joules, which is option A, 13 joules. Now these are the type of questions that are so easy that the student would in most cases think that they've done it incorrectly. Question 17 says a turbine of hydroelectric power station is situated at a vertical distance of 30 meters below the level of the surface of a large lake. The water passes through the turbine at a rate of 340 meter cube per minute. The overall efficiency of the turbine and the generator is 90%. The density of water is 1000 kilograms per meter cube. What is the useful output power output of the power station? So what's happening in this case is that gravitational potential energy power output is due to gravitational potential energy per unit time, but there's an efficiency of 90%. So the rate at which GPE decreases, 90% of that gets converted to the output power of the power station. Now what is the mass? The mass is not given to you, but we do know that mass is equals to density multiplied by volume. So we can write down the same formula as density multiplied by volume, GH upon T multiplied by 0.9, which is 90%. So density is 1000, volume is 340, so multiplied by 340 into 9.81 multiplied by the height, which is 30, per unit time. So there's 340 meter cube per minute, and since we want the answer in watts, I'll convert minutes into seconds. So this should be 60 seconds, and 90% of that is the output power, which comes out to be 1.5 into 10 to the power 6 watts, where 10 to the power 6 represents mega. So 1.5 megawatts is our answer for question number 17. Question 18 says a projectile is launched at 45 degrees to the horizontal with initial kinetic energy E. Assuming air resistance to be negligible, what will be the kinetic energy of the projectile when it reaches the highest point? So for this projectile, let's say the initial velocity is V, and this is at an angle of 45 degrees to the horizontal. This projectile has a horizontal component. This horizontal component is V cos 45, and this projectile has a vertical component which is V sin 45. When you talk about the maximum height, at the maximum height the vertical component is 0. So the projectile only has a horizontal component which stays unchanged because air resistance is negligible. So at the maximum height, the only speed that it possesses is due to the horizontal component of velocity, which is v cos 45. Now I can use ratios. I know that kinetic energy is directly proportional to v squared. Kinetic energy is equal to half mv squared, hence kinetic energy is directly proportional to v squared. So the energy was E, initial kinetic energy, when the initial speed was v. What will be the kinetic energy? Let's call this x when the speed is v cos 45, but don't forget that it's v squared, so this gets squared, this gets squared, and when we cross multiply, we end up with x being equal to 0.5 e, the answer being A. Question 19 says a wire is extended by a tensile force so that its deformation is elastic. What is meant by elastic deformation? So let's go through the options one by one. Option A says the extension of the wire is proportional to the tensile force. That has nothing to do with elastic deformation. That is valid up till the limit of proportionality. The elastic limit could be beyond that point. The extension of the wire is not proportional to the tensile force. No. Option C says when the tensile force is removed, the wire does not return to its original length. Does not. So that is plastic deformation. When the tensile force is removed, the wire returns to its original length. That is elastic deformation. So the answer is D. Moving on to the next question, which is question number 20. A bolt is subjected to a tensile force as shown. The bolt has a circular cross section. At end x the diameter is 2d, at end y the diameter is d. What is the ratio of the stress at y to the stress at x? So what is stress? Stress is force upon area. Now when you compare the areas, we know that area of a circle is pi r squared, which can also be written as pi d squared upon 4 or pi into d upon 2 whole squared. Now when we talk about the areas here, let's say the area of end y is A. So for a diameter d, the area is A. For end x, since the diameter is double and area is directly proportional to diameter squared, when the diameter doubles, because of the square, the area becomes 4 times. So at end x, the area is 4a. The area is equal to 4a. Which means for the same stress that they experience, the stress at y would be force upon area. The stress at x would be force divided by 4 times area, which can be written as F upon A multiplied by 4A upon F. The F's cancel out, the A's cancel out. The ratio of the stress is equals to 4 upon 1, which is equals to 4.0, which is option D.